Hello, welcome. Hopefully you and your partner now have done a good job of working through the entire Part A and Part B for the exploratory problem set. Here in this quick video explanation, I'm going to talk to you about a few key things you should have seen. So what we're looking for in these descriptions is for you to be as precise as possible. The word precise means we want you to describe with as much accuracy and detail, using numbers, using math as much as possible to tell us what's happening as we look at some of these transformations. So for this first one, the blue one, XYZ, hopefully most of you saw that you should say something along the lines of XYZ was moved up, it was dragged up. If you started to use some fancy math terms, you might have called this a translation. Some of the best answers would have talked more precisely. They would have said XYZ moves maybe from quadrant 3 up to quadrant 2. Even more precise, you could have talked about specifically how many units XYZ moved up. For the second one, hopefully you and your partner talked something about, again, here all we had to do for the green pentagon, A, B, C, D, E, to get to the new image of it, A prime, B prime, C prime, D prime, and E prime. That's what this little dash means. Again, all we did was drag it or move it, but this time not only did we drag it down, we had to drag it down and left, or we could say maybe we dragged it left and then we dragged it down. What we could show you here real quick, we see if we had just taken A, B, C, D and we moved it left and then we dragged it down a bunch, all we really have to do is move it, and then that gets it at the end of the day to be in the same spot as this other pentagon. Again, more precise answers would have talked about going from quadrant 1 all the way down to quadrant 3. They might have said how many units left, how many units down. Those all would have been great, precise answers to describe exactly how far left and how many units down it had to go. For the other two, the red problem, hopefully we saw that for the red trapezoid, PQRS. Here it's something a bit more complicated than just dragging and moving. Because if we take PQRS and we just drag it and move it to the right, it's not going to line up there. It doesn't fit. We see something has happened as PQRS kind of gets tipped over to the side here. It got tilted over or spun around, and now I see when I spin it around, I could get it to match like that. So you would talk something about we spin it or we rotate it. The math term that we're going to start using specifically is rotation, and that's when describing when we take an object and spin it around like we see with the red object. The best answers would have gotten more precise. They would have talked about the number of degrees. They would have talked about direction being clockwise or counterclockwise. That's really all stuff for a future day that we'll get into. But the biggest thing we could see, if you think about this graph as being a clock, it looks like we don't spin. A clock would spin. If you look at my mouse right now, take a look where my mouse is. This is how a clock would spin in this direction. We didn't spin in the direction that a clock spins. We actually spun backwards, the opposite direction of a clock. So we should say that this spin is actually a counterclockwise spin. We'll talk about why it's a 90-degree spin in future days. If some of you saw that, that's impressive stuff. For the last one here, we can't spin, actually. If I took this and I just spin it, there's actually no way to get FGH to match the new FGH here, FGH prime. We're going to talk about, hopefully some of you started to say it looked like we flipped it across or we reflected across a mirror. So again, this term up here, reflection, is what we see happening here in the purple graph. It reflects because we see that this purple triangle just gets flipped across the y-axis. F and H are upside down here, F to H. Here it's still F to H, but now they're on the right side of G instead of the left. What happened is they flipped across. Again, we're going to get more into rotations and reflections on future days. We just want to start getting familiar with what a rotation or reflection might look like. And hopefully you were able to match the terms up here in the term bank based on what we just discussed up there or with your partners already before this video started. If you've got questions about the exploratory problems, definitely let me or Ms. Stewart know. You should be making sense of the exploratory problems every day and writing a sentence about what you learned by exploring on your own and looking at this video at the end before the practice problems get going in the second half of class.